Greetings, Earthlings. Today we're going to actually try to run some microcode on the stupid computer. So I'll be assembling it and actually running a little test program. I've got all the boards completed, as you can see here. That's the top board, TTYIO, with the chips installed, by the way, yes. TTYIO, this is the front panel driver. We'll get back to that. This is the microcontroller board. The microcontrol PROM, well, it's flash memory, goes here. I've left out the RAM for now. We're not going to be needing it for this test. And the bottom board, it's the ALU, the multiplexers for the A bus and the B bus, and the registers are over here. So B bus, registers, there we go. And that's some just miscellaneous logic. So I need these little standoffs. Let's see. I am going to go like this and like this. Right. Like that. Oh, and by the way, this is the power supply. For the moment, I just have it wired directly to the power plug, and then I hide it inside the box so I don't electrocute myself. There's no fuse in there or anything. We'll just have to rely on the power strip to act as a power supply, which it probably doesn't. Okay. And number 3 goes, let's see. I know this is really exciting. Believe me, it'll get more exciting in just a minute. Okay. That's number 1. Number 2. Oh, I can't plug this one in yet. By the way, this connector here is a connector that I had. That's how I'm going to bring the power into the thing. The power gets distributed between the boards on some pins on the bus here, but I'll be bringing it in through there onto the middle board, and then it gets distributed. Okay, well, I could actually plug this in, but we've got to get the ROM. So let me talk about the code. Now, I have not yet, this won't be the complete code for the stupid computer. I'm in the process of writing a microcode assembler. So, and I haven't really tested this at all except for the last test you saw, which was just sort of hard wiring, jumpering between things. So we're going to test the sequencing and such. I've hand-coded a little microprogram. It's all of 9 instructions. But what this is going to do, set the accumulator to 0, set the memory address register to 0, set the memory write register to 0. Now that's not something we can see. The accumulator and the memory address register show up on the LEDs here, so those should blank out. Set the PC to the value of the memory address register, so the PC should also be set to 0, and that's on there. Mem data is going to be floating, so the lights will probably mostly be on. Maybe, who knows? They'll be random. So this is testing the registers, the basic registers, not the indirect registers, but the basic registers and the ALU operation, some of the ALU operations, that I can move between registers, that I can actually set something to 0. Then I have a loop here, which is going to test conditional and unconditional branching and terminal I/O. All it does is it's going to echo characters from the keyboard to the terminal out. And we'll use the Silent 700 for that. So there's a conditional branch here waiting until there's a character ready. Let's see. And then this one is, this one here These next two instructions are waiting for the transmit buffer to be empty. That's what BTBE, branch of transmit buffer empty. Okay. Move the contents of TTY in to TTY out, and then branch back to the loop. So that's actually testing quite a bit, given that it's only 9 instructions. But in order to do that, we've got to program the flash memory. Okay, then. So here's the code. Whoa, backlight. And I need to do each of the bytes separately into 3 separate chips, high, mid, and low. Isn't that nice that they sent those pre-labeled to me? And we're going to be using this device to program them. So let's get started. I'm going to take the high. I'm going to take the high byte, and there's the notch right there. So the notch is going to go, this is how this works. You put it up as far as you can that way and lock it in. Okay. Let's go ahead and read it. Make sure it's empty. I've already set it here to the correct device, which is the SST39SF010A. Okay, we've read it. And you can see it's empty. It's full of Fs. So I'm going now to enter the high byte, which goes, right about there. 00, 01, 02, 01, 10, 20, 70, 03, 70. Okay. Let's see. 00, 01, 02, 01, 10, 20, 70, 03, 70. Okay. That looks correct, so we'll go ahead and burn that. And that one's done. Okay, and we're back. Here's our flash memory that we've just programmed. I'm going to keep this hanging around. I am going to plug that in. Hopefully it'll fit. There's the notch. Goes high, mid, low. Okay, there we go. Leaving the RAM out for now. This is the clock, by the way. Got a 10 megahertz clock in there. Yes, we're going to run it. Well, it gets divided by 2. So the little thing, this is running at 5 megahertz, 200 nanosecond microcycle time. And yes, we are going to run it at that speed. We're not going to, until we determine that there's a problem, and then I'll go to sort of single stepping it. Okay, now, here's our stacking headers. You can see those just slide together. Very nice. Very nice. Okay. And of course the boards are warped. I got no control over that. Oh, and I don't know if I've shown this. This is the status indicator, the error indicator, which I'll have it do like a power on self-test. And then if there's a problem, it'll indicate it on those. This is going to sit in the case. Yeah, I'll show. See, the front panel goes like this. Okay. And then these boards will sit behind it in this orientation. And so there'll be a little viewport out the back. Or I'll make the back panel of the thing out of Lexan or something. Now this is the first time that these have actually been together. I did not try this ahead of time. Oh, let's back up. Okay, in terms of this is going to be, let's see. I better get this right. So I'm going to pull this apart. Okay. I believe 1 is +5 and 8 is ground, is how I wired it. But I marked it. Yeah, okay. So that's a plus. I don't know if you can see it. That's a plus. That's a minus. So this gets +5. This gets ground, and it is 5 volt only. Through the magic of this chip, which does the level conversion to RS-232 compatible signals. Okay, and then the front panel plugs on here. Now, this one, and actually this one goes here, this one goes here. I know that, but one way to sort of verify that is you can see these are power and ground here. And looking at that board, there's some heavier connectors, not the little blue things. And so, those are power and ground. So, and they're keyed. That's going to go in there. And that is going to go in there. Okay. Okay. Extra points to anyone who noticed that I didn't hook up the power supply, and that I really, since the screws are on top, I really need to do that before I attach this board. So this board has to come back off. Okay. What did I say? What did I say? Well, let's look again. 1 is plus, 8 is minus. Okay. These are wimpy leads. I actually don't know how much current this thing draws. These are rather wimpy leads. The power supply is rated for 7 amps, which I'm hoping is enough. I kind of figured it out, based on the data sheets, but I really do need to measure it before. Well, no, I can't measure it before I use it. I just have to trust it for now. So if it goes up in flames, either the power supply conks out because it's current limited, or if these wires melt because they can't take the current, you'll get to see that. Okay, power supply on. Now, when I plug this in, what should we see? We should see PC, AC, and mem adder go to 0. Mem data, again, will be somewhat random. So, quick plug and unplug just to see if anything sparks fly or anything. Okay, didn't see anything. Oh, well, that's not good. That's not good at all. Okay. Very interesting. Notice the randomness on the mem data, but I've got inverted value here, and I've got it not echoing at all. So, I've got work to do. Okay, after a bit of debugging, it appears the primary problem was in my hand assembling of the microcode. There may also be an issue with the TTY interface. I'm not sure. So I've simplified the microcode, the test code, down to 5 instructions. Set the accumulator to 0, set the memory address register to 0, set the memory write register to the value of the accumulator, set the PC to the value of the memory address register, and then branch to FF5, which will light up those error lights, okay, and FF5 branches to itself. So those, I should get 0101, basically. I should get what looks like a 5. Okay, so let's plug it back in and see if the screen or if the lights go blank this time. Well, that's better, huh? And of course, the mem data is still floating. I set MWR, which is not the same as mem data, and MWR is not one that we can look at on the front panel. Okay, and then so what about the front panel lights? Or not the front panel lights, the error indicator, okay? Read it top down 0101, that's a 5. So, yeah, I need to get that assembler going, the microcode assembler going, to do any proper testing, because it appears I am horrible at hand assembling this stuff.